Hello everyone, my name is Federico Tenga. I'm part of the Bitfinex team working on RGB development, which is here also represented by Zoe and Nicola. They are the guys that do the actual artwork. And what we're going to talk about today, of course, RGB. I will try to give an overview of the RGB protocol and show a little bit in particular the work done by our team in the past few months. So first of all, before talking about RGB specifically, let's have a look about what we usually consider smart contracts, because like the goal of RGB is also to provide an alternative method to write contracts. So the term smart contract is actually like older than Bitcoin and the blockchain itself. I mean, it's a very old term that was originally defined by Nick Szabo in an article in 1994, and the definition, like at the time the blockchain didn't exist yet, so the definition was like a computerized transaction protocol that executes the terms of a contract. Then the term smart contract wasn't really used that much anymore. When Bitcoin came out for the first time in 2009, it like the scripting language of Bitcoin actually fit the definition of smart contract, because when I do a Bitcoin transaction, basically I define that a certain amount of Bitcoin can be moved if you meet a certain condition, which usually is just provide the signature for a certain public key. But like from the very beginning, the scripting language also supported the more complex contracts, such as like hash lock, time locks. But at the time, like nobody really called it a smart contract. The term smart contract was then popularized only later by Ethereum promoters. But then, like the general understood the definition in with the new revival of the term became something more like code that is redundantly executed by all nodes in a global consensus network. So now, like most people consider smart contract code that I can push on the blockchain, and all the nodes in the network will execute the same code, and the fact that everybody execute the same code is sort of the guarantee that code will be executed correctly. So we delegate all the participants in the network the responsibility to make sure that the contract is executed correctly. This is like an approach that has both advantages and disadvantages. A clear advantage is it is very easy to deploy also complex contract, because basically, you delegate all the complexity to a decentralized network. But it's like both a feature and a bug, also because like when you can easily deploy complex stuff, it can happen that something goes wrong, which happened a few times in Ethereum. But I mean, like everybody is free to choose his own trade-off. So if you are willing to take a risk to have some easier user experience and easier feature, I mean, there's nothing wrong with that. But there are a few downsides, a few obvious downsides in having a whole network executing the terms of your contract. First of all, if everybody have to execute this code, the amount of code that in general can be executed cannot be too much, because simply we are limited by the computational power of our computer, and if a network is decentralized, is truly decentralized, most people will not have like a supercomputer to execute a large amount of code, because like if everybody needs a supercomputer, then there are not so many people in the network, and so it's not decentralized anymore. So there is a lack of scalability, or I mean actually either scalability or decentralization, because if you want to keep it decentralized, the amount of code that is executed by the network cannot be too much, so you have no scalability. Or you decide not to care about decentralization, so you have like very large blocks that only few people can actually validate and run, and then you lose decentralization, but then you kind of miss the point of having all this infrastructure in the first place. The second drawback of putting all this code on the blockchain is that all blockchain observers can see what you're doing, which maybe you don't mind, but maybe you do. And so yeah, in general, for most people, privacy is usually a good thing. So this is kind of another drawback of pushing code on a global consensus ledger. And the other disadvantage is that if everybody needs to validate the code, we kind of need to all agree on the validation rules, which maybe is fine when the network is small, but as the network grows and becomes actually truly decentralized, if we want to change something, it's really hard to agree on it. So it's quite hard to upgrade when an entire decentralized network of people that don't know each other, of people that are mostly anonymous, needs to agree on something. So it would be nice to have an alternative to this model. And a nice alternative will be to have contracts that are executed only client-side. So the idea is that every wallet, every user has run codes on his device that only execute the code that is relevant for him. Only the wallet only cares about the contracts that are relevant for what the activity of the wallet. So right now, like when you run a Bitcoin node or an Ethereum node or whatever, basically your computer, your device keep validating all the time stuff that you really do not care about. Like 99.999 of the Bitcoin transaction happening on the network, they are not relevant to me. Actually, the only transaction I care about are the ones that are sending something to me, because I want to make sure that what I'm receiving is real, is not being counterfeit in any way. And so there is like a lot of work that like we do, but we don't really care about. So another thing that would be nice is that everybody only see the contracts that is involved in. So we don't need to, not only maybe we don't care about other people's activities, but also we don't want other people to see our activity. So it would be nice that everybody only see the stuff that is relevant for himself and cannot spy at random people activity. And a third nice feature will be that only the parties that involved in a contract need to agree on its execution rules, because maybe like I want to do something weird with my counterparty, and we agree on that, but we cannot make the whole network agree on the same validation rule. So it would be nice if we can make a custom contract that we don't need the rest of the world to agree on. So all of this that I just described actually is nothing new at all. It's more or less how it works with normal traditional not digital legal contract. So like for example, in England until 1998 it was not compulsory to register a real estate transaction in the central land registry. So because of this, still today, about 15% of all the land in England is so-called unregistered property. And so when you buy an unregistered property, basically you cannot go to a central registry to check, okay, the seller is really the true owner, there is really like an unbroken chain of ownership, and there is nobody that can have a claim on the land that I'm about to purchase. So if there is no registry, what people do is that they have this like paper title deeds that can prove that you're the real owner because you bought from the previous owner. So when you buy this kind of property, what you usually do, you like check an unbroken chain of ownership that go back up to 15 years. 15 years is considered like a long enough time frame that there shouldn't be any hidden party that has a claim to that land. And you check that there is unbroken chain of ownership. You check that all the mortgages that were used to buy that land previously has been completely fully paid off. So you check a bunch of stuff, and then you are fairly sure that what you're buying is actually owned by the seller. And this has all the advantages that we saw before. So basically, only the parties involved can see that this transaction is happening. There is we don't need to trust as a maintainer of the central registry, and yeah, we don't need to ask permission to the central registry to do things maybe a little bit different. but also he has obvious drawbacks that is much more work to make sure that what you're buying is actually owned by the seller compared to what you do with a central registry. So the idea is that maybe we can improve this model for contract using technology. So a good way to improve this client-side contracts is first of all to make it digitalized and have like a standard code that computers can execute to validate that each ownership transfer is valid. So we don't need to do it all of it manually. We just put something into a computer. The computer will tell us it's valid or it's invalid. Second upgrade that we can do is that we can commit each ownership transfer to a public ledger to avoid double spending. So basically we use the public ledger not to put the content of the ownership transfer, but just a commitment so the seller cannot sell twice the same thing. And as a buyer, I have the guarantee that I am the only one that actually received that asset. And the third thing is to establish a convenient communication channel between the parties, between the computers of the two parties involved, to exchange all these proofs that prove that the ownership transfer is actually valid. So this communication channel can be anything. You can use pigeons if you want to, but it's like more practical to use some digital communication channels. And yeah, there is a number of ways you can do it, and the protocol can also be agnostic. Like parties can just agree on what they want to use. So regarding the commitment layer, what we can use Bitcoin. Why? Because Bitcoin is probably like the best and most secure public ledger where we can commit data to. So the basic idea is that each right, or like more specifically token in case of asset issuance contracts, which is also like the main use case for RGB in the short term, asset issuances. Each token, it's allocated to a Bitcoin existing output on the blockchain, to a Bitcoin UTXO. And this Bitcoin UTXO, it will work as like a so-called single-use seal, which is also a concept that was promoted a few years ago by Peter Todd, that we have here. And so basically the idea, we assign this asset, this right, this token to an UTXO, and when you want to move this token, you need to prove that you are the owner of the UTXO. And how do you prove it? By spending the UTXO. And by spending the UTXO, also you make sure that you cannot do it twice, because we leverage all the guarantees that the Bitcoin network provides, that there cannot be double spending. So yeah, of course you can still have reorgs, but just as you do with normal Bitcoin transactions. So a token is assigned to a UTXO. When I want to move the token, I prove to my counterparty that I am the owner of the UTXO by spending it. And when I spend it, I create a Bitcoin transaction. And inside this Bitcoin transaction, I put a commitment of the body of the ownership transfer that I'm doing. So in this way, I say, okay, me as an owner of this UTXO, I'm committing to do this ownership transfer in this way, and I cannot do it twice because I can spend the UTXO only once, and I can put the commitments into the transaction only once. Of course, like to do this, you need to have like a standardized protocol where we define where the commitments needs to be in the transaction, and but yeah, we just need to agree where to do it exactly, and it's quite feasible. So in this way, the owner has exclusivity over the transferring of ownership, and the miners of Bitcoin, they're only mining a normal Bitcoin transaction. They don't even know that there is something else happening in the Bitcoin transaction, because it's just a normal Bitcoin transaction, and the parties benefit from all the double spending protection of Bitcoin. Keep in mind that like we're using Bitcoin just because it's the best choice that we have, but we could potentially use anything else. For example, we could use just like the first page of the New York Times. We define, okay, when you want to move this token, you have to put the hash of the body of the transaction in the top right corner of the first page of the New York Times. We could do that, and it maybe could work quite fine, but we have a few disadvantages. First of all, yeah, we're trusting the editor of the New York Times not to mess with it. Then it's not really scalable because basically every users will need to have a dedicated spot somewhere in the New York Times. So like basically it will become, if too many people start using it, basically it becomes a paper only of full of hashes, not much content. And also the editor could both do censorship, or even worse, put in your spot a random hash. So when the buyer tries to do the validation, think that asset has already been spent because somebody put a random hash in your spot. But with Bitcoin, we avoid that because only the owner of the UTXO can create the transaction that contains the commitment. So it's the best way to do it, and yeah, it's the best blockchain compared to all the others because we have more security behind it. And also, like, to do this transaction, we can pay with Bitcoin rather than a random shitcoins that we may not be interested in. So to pay the fees, we are using an asset that we already hold for other reasons.
Sorry, a quick question. Normally, isn't Ethereum meant that it's the best smart contract? Why are you using Bitcoin instead of Ethereum?
So the question is why we are using Bitcoin instead of the Ethereum when Ethereum has the reputation to have the best smart contract. Is that we don't need the smart contract capabilities here. We don't care about Turing complete and all this kind of stuff. We just need to put an hash inside the transaction one way or another. So it's the most simple thing that you can do. You don't need to use all of the Ethereum smart contract flexibility. So, sorry? Yeah. It's just that we don't care about that feature. We just need it to be safe. We just want the most secure blockchain. We want to maximize security because we are doing something so simple that we don't need any special feature. So it's just something that we are not interested in to have smart contract capabilities on the blockchain, because then we will try to have them off the blockchain. Okay, so let's have a look at on how that can work in practice. So first of all, we will have an issuance contract. In the case of token issuances, which is the main use case for RGB at the moment, where we define a few things. We define maybe the name of the contract, the ticker of the contract, the max supply, and then this is very simplified. Then you can add extra metadata, or you can add also the possibility to have secondary issuances in the future. But let's keep it simple for now. And basically, in this issuance contract, you define the first owner as a certain UTXO. So here I'm saying I'm creating this red token with a supply of 100 units, and these 100 units are all assigned to this UTXO A. Actually, I could also assign it to multiple UTXO. I can say 50 to A, 50 to B, but for now, let's keep it simple. Then this owner of the UTXO A wants to sell it to someone else. So he creates this ownership transfer. That would be this RGB transfer that move the tokens from UTXO A to the UTXO of the receiver. So in this case, we are moving 20 red tokens to UTXO B and 80 red tokens to UTXO C. Why? Because there is we need to get the change of the transaction. So the owner of the UTXO A will send maybe 20 tokens to his counterparty and 80 back to another of his UTXO as change. Then later on, and all of this transaction, we do the hash, and we committed inside inside the Bitcoin transaction that is spending the UTXO A, and there can be only one of them because I cannot spend the same UTXO twice. So in this way, the owner of the UTXO B is pretty sure that now is the new owner of the token because. The previous owner created a transfer that is committed in the right Bitcoin transaction. And then this can go on with the owner of the UTXO B, sending it to the owner of the UTXO D, and so on and so forth. So going a little more into details on how that work, basically we have this body of the RGB transfer, which has input and output. and the commitment goes inside one of the outputs of the Bitcoin transaction. So the way it is implemented right now in RGB, there are two ways to do this commitment. Now is by putting the hash of the body of the transaction, actually to be specific, the top hash of a Merkle tree of multiple transactions, because you can actually move multiple tokens at the same time. We have two ways to do it. We can put it either in the first op-return output of the transaction, or inside the tap tree of the first taproot output. So the op-return solution is less elegant, but with less complexity, so easier to implement in a wallet. And the taproot one is much more elegant, but has a bit of extra complexity. So it was decided to keep both options to facilitate the life of wallet developers. And yeah, of course, like the taproot one also has the advantage that it makes it even harder to suspect that this Bitcoin transaction is somewhat involved with RGB, because you just see like a transaction moving from one output to another taproot output, that usually will be an output of the sender, where he sends back the satoshis that were associated to that UTXO. And yeah, really, you don't have any way to even suspect that there is an RGB transferred connected to this Bitcoin transaction. With op-return, also you don't have the guarantee that is an RGB transfer, because people put op-returns in transaction for all kind of reasons. But yeah, maybe it's a better heuristic to think, hey, maybe this is an RGB transaction. But still, you have no idea what's the content of the transaction. So a blockchain server still cannot do too much to violate the privacy of the users. So since this is a client-side model, basically every time I receive a transaction, I do not only need to validate that what I received is all valid, follow validation rules, and was correctly committed into the Bitcoin blockchain. That is not enough. I need to validate all the history of whatever I received until the genesis of the asset of the issuance contract. So basically, in this example, like we just received the payment P, and to be sure that this payment P is correct, we need to validate this transaction, and all the transaction going back to the genesis. But this doesn't mean that I need to validate all the transaction of the asset, because there is maybe like other transaction that I do not care about. I will not even be aware of their existence, because they are not connected to the history of my asset. So in this way, we have like better scalability, because we only validate strictly what is necessary for us to validate that the payment P is a valid payment, and also like better privacy, because like other people don't see the full history of transaction, only a part of it. So nobody actually have a full map of everything that's it's happening in the network regarding a certain asset. They only can see part of it if they are one of the parties involved in one of the transfers. So regarding the capability that has RGB right now, basically right now there are only like two contract schemas. One is called RGB20, is made to issue fungible tokens. And one is RGB21 that is basically a variation of RGB20 that is used for collectible tokens. You can also add media files, and there are like a few small differences.
Like
but
NFT stuff?
Yeah, like NFT stuff. I call them collectible because like NFT is a very specific term, non-fungible tokens. But in this case, the schema also allow you to make them fungible. You can also issue like 100 of them, or as many as you want. So yeah, collectible is a more generic term. But yeah, you can do an NFT if you do with a max supply of one. Yeah, it's technically an NFT.
You can put it on top on Lightning Network, I don't know.
So regarding the Lightning Network part, yeah, with fungible token, it will be possible. It's not implemented yet, but it will be possible. With non-fungible token, it's really not possible because Lightning Network is based on the assumption of fungibility, that the stuff that is in my channel is fungible with the stuff in another channel. So fungible token can be in the can have their own Lightning Network. Non-fungible tokens they just can't. But yeah.
Channels back and forth but not routed.
Yeah. Technically, you could have a channel that you send back and forth on non-fungible tokens, but I'm not sure if there is a valid use case for that. But maybe yes, I don't know. Yeah, maybe with a marketplace, like you put an NFT as collateral and then you take it back and you put it as collateral again. Could be a use case, but yeah, I don't know how realistic it is that it will actually happen. But yeah, the cool stuff about the way RGB was developed is that it's very flexible. So yeah, this is the two schemas that are available right now, but everybody can create his own schema. I know that there are people that have ideas for schemas for identities and other stuff. And you can do it like without asking permission to anyone. You can write your own schema. You can put it in your like RGB node, and yeah, whoever is interested to use the schema, they just need to put it in their RGB node so that you can understand it, and we don't need to all the RGB users don't need to agree on which schemas are valid, which are not. Everybody can make his own schema. You can make also a very terrible schema that everybody will agree that is a terrible one, but it doesn't matter. You do it and you just need to convince your counterparty that it's good enough for your scopes. So there is a strict distinction between RGB developers that work on the RGB code and schema developers that work on the different schemas that can enable different use cases. And then you have the application the developers that make sure that all this stuff is usable to normal people. So let's have an overview of the core features of RGB and why this is it can be useful for people to use RGB. On top of everything that we just described, we also have a feature that basically hides the out point, or like the UTXO, where we're sending the money. So basically, when I'm paying someone, the body of the payment doesn't define directly I'm paying to UTXO B or UTXO A. Basically, I'm paying to the hash of a concatenation of your UTXO and a random number. So in this way, I do not know where I'm sending the money. I have no idea. I just see like a random number. But the receiver will be able to prove to future owners that that blended UTXO actually correspond to a real UTXO on the blockchain that is producing a real Bitcoin transaction that they can verify. So this is a very cool feature because right now, if I send Bitcoin to someone, yeah, like this guy can generate a new address, so I don't see all of his other activities, so I can have decent privacy. But still, I can monitor when he will move those Bitcoins. So maybe like if I send Bitcoin to someone and say, okay, this is the Bitcoin, but like don't move them for a few years for whatever reasons. Like or even like I can monitor on the blockchain if they're doing it or not, or even like I don't say anything, but I can check. Oh yeah, this guy moved the money, so maybe he's doing something. In this way, I don't know where I'm sending the money, so I have no way to monitor future activity of the people I'm paying to. So this is like a quite cool privacy feature that like not many systems have right now. Second privacy feature that has been implemented is the bulletproof cryptographic mechanism that basically makes sure that in the history of transactions, the amounts are hidden. So also future owners maybe can see your UTXO because they need to validate all the chain of UTXO transfers, but they cannot see how much tokens have been moved at each step. So it's also like a nice feature that RGB provides. Then regarding the scalability part, we have transaction batching, which provides scalability on chain. So this is like before layer 2 protocols, where basically with a single Bitcoin transaction, you are able to commit an arbitrarily large amount of RGB transfers. So what is the use case for this? Let's say that I am a service provider, maybe I am an exchange, and I have a bunch of users that are asking me to withdraw tokens in the same time frame. I can operate all of these withdrawals. It can be like 1, 2, 10, 1,000, 1 million of them. I mean, with big numbers, then maybe it will be a bit. You will need a bit of computational power to do all the stuff. But technically, a large number that not too large that your computer will explode. But there are no technical limitation on that. A arbitrary large number of RGB transaction can be committed to the same Bitcoin transaction. So I can operate maybe 1,000 withdrawals at the same time, also for different assets, with one single Bitcoin transaction paying the transaction fee of a normal Bitcoin transaction with one input and one output. So I can pay maybe a few hundred satoshis for all of this withdrawal. So making the marginal cost of an RGB transfer in this case almost insignificant. This of course only works for if you are doing a lot of operations at the same times, and only works if you are moving from the same UTXO. So you need to have all these assets on the same UTXO. If you have them on multiple UTXOs, you can still do some batching, but you need to add all these UTXO in the Bitcoin transaction, so it may grow in bytes. But this is a very cool feature that can make service providers save a lot of money. Of course, as an individual user, I can leverage less of it because I'm less likely to do a lot of operations at the same time, in the same time frame. But still, it may happen. Maybe I'm paying a bunch of people at the same moment for whatever reason, and I can still leverage this feature. So we have scalability on chain. So another thing that I didn't put in the slide is that when you do issuance of a contract, that issuance is not an on-chain event. Basically, when you do issuance, I'm creating a contract where I say, okay, I'm creating 100 tokens with these characteristics, and the owner of this token will be UTXO A. But this does not need an on-chain event. I don't need to do a Bitcoin transaction for that. So issuance is actually for free. I will just pay the normal Bitcoin transaction fee the first time that I move the tokens to someone else. So maybe this can be a useful feature for people issuing very low value tokens that may or may not have a market value in the future. So I just start issuing them. Then if a buyer show up, good, I can pay the transaction fee because I'm receiving something to sell the token. If nobody shows up, I didn't spend anything, so it's not a big loss. While with Ethereum, you want to issue an NFT on Ethereum, first pay crazy transaction fee in gas, then let's see if somebody wants to buy it. So it's a nice feature for a lot of token issuers. And then, of course, being all of this built on top of Bitcoin transaction is also compatible with the Lightning Network, because at the end, the Lightning Network is just a bunch of Bitcoin transactions that we may or may not settle on the blockchain, but they're still Bitcoin transactions. So you can basically RGB transfers can be committed to a Lightning Network channel update that may or may not end up on the blockchain, but it doesn't matter. Then if you decide that you want to update the balance between the two parties to something else, you do a channel update, you commit the new balance of RGB token between the two parties in the new channel update, and then again you may or may not settle it, but you can build a Lightning Network for RGB token. This is still work in progress, it's not delivered yet, but there are people working on it. Regarding this, there are a few limitations to be aware of. First of all, as we were saying before, Lightning Network is based on assumption of fungibility. So you cannot use existing Bitcoin liquidity to move token, because you need to have channels that for the new tokens. And this means that probably only popular tokens, popular assets, will be able to create a large Lightning Network comparable somewhat to the existing Bitcoin one. Smaller smaller asset, less popular one, they can still maybe have a Lightning Network-like experience, but it will be probably, I guess it will be more like an hub and spoke model with a few very centralized nodes. But then we have to see in real life what will happen. An idea that was jumping around, not only in RGB but also in other similar projects, is to have nodes that can exchange between one asset to Bitcoin, and then use the Bitcoin liquidity to route the payment, and then at the other end you change it back from Bitcoin to the asset that is the object of the payment. This in theory works, but in practice I do not expect it to work very well, because if the asset is not popular enough to have a direct route of channels to your counterparty, it's probably not popular, also not liquid enough to have a decent spread when you are exchanging from the token to Bitcoin and from Bitcoin to the token back. So you have to pay twice a spread that probably will be quite high, and so maybe it's just cheaper to do an on-chain transaction. But I don't know. I mean, we will see. Like this thing needs to go in the real world before we can do a final conclusion. But yeah, my idea, my suspect is that that model will not really work that well in practice. Okay, so regarding the RGB ecosystem itself, it has grown tremendously over the past few years. So now we have a bunch of companies and products that are built on top of RGB. I may miss someone. I don't know. These are the ones that I am aware of. I know that there are other people that are doing their own like stuff on RGB that may not have it advertised so much. So if somebody is doing something RGB and I didn't put it here, like don't be offended. Come to me and next time I will put you on the slide. But yeah, like this is of the people I am aware of. These are the companies and products already involved in RGB development. So yeah, Bitfinex is like our team. Then there is Diba, which is an American company that is working on NFTs on top of Bitcoin. Fulgur Venture, which is also very involved in RGB development. There is Pandora Core, which is the company of Maxim Orlovsky, which is one of I would say the main developer of the RGB protocol for the past few years, and he also has his own company where he does products. And then there is the LMPBP Standard Association, which is a no-profit association that financed RGB developers in the past few years. Then in products there is Iris Wallet, which now I will present is the wallet that we made with our team in Bitfinex. MyCitadel, which is the wallet that is working on the Pandora Core. Bitmask is the wallet that Diba is working on. And RGB Tool is a set of open source tools that we build with our team to facilitate RGB development for application developers. So it's basically mostly like a library that then I will talk more about it later. So, but let's look about like what we worked on with Iris Wallet. So Iris Wallet is an Android wallet. It's been released like a few days ago, and is available both in the testnet and mainnet version. So yeah, like technically you can do RGB transfer on mainnet already. I do not recommend it to do it with something that is valuable, because I mean all this tech is still like in experimental stage. This is also why the mainnet version of the app is quite limited compared to the testnet one. But yeah, you can download it and you can like issue assets, transfer assets, and both like fungible and collectibles, and yeah, a bunch of other stuff. So for this conference, for the occasion of this conference, we also implemented a feature like a faucet where you can request free collectibles that you can receive on your wallet, just like to play around with it and to see that you can actually receive something. And this is available both in the testnet and mainnet version. They are like different tokens, but yeah, like if you just want to play with it without putting real money at stake, download the testnet version. You can load some testnet Bitcoin balance, because you need to create a few UTXOs in order to be able to receive assets. So that's why you need a Bitcoin balance. You ask for a free token, you will receive it, and you can send it to someone else, or you can issue your own one and you can start playing with it. In the main version, we also made the mainnet version, but in that case, yeah, you need to put real Bitcoins to have a Bitcoin balance to create UTXOs where you can receive assets. But yeah, like maybe if you believe that this token, the first like collectible on RGB in the future may have some value, you may be willing to put a few satoshis for this, and like all of them waiting for, maybe hoping that in the future people will be interested in them. The wallet asks you to have at least 10,000 satoshis balance to create a few UTXOs. So yeah, like you need to upload that to be able to use it. This wallet is still like very experimental, so like be aware that something could go wrong. For example, something that we do not have yet is backup functionalities, because with RGB it's not that you just export your mnemonic and then you can recover all your assets. In RGB, basically, every time you do an operation, it's new data that you need to store, because when you will then spend your token, you need to provide this data to the receiver so that he can validate that you are the real owner of the asset. So every time you do an operation, you have new data to backup. So we are working on an automated backup feature to this for you. Like you can send the unencrypted backup to your Google Drive or to your own personal remote server. But it's just not there yet. I mean, we are working on it. It will be delivered soonish. But yeah, just be aware that for now, if you lose your device, you kind of lose everything. And yeah, also for the occasion of this conference, we have an artist called Proof of Paint that made a real physical art that is exposed upstairs at the art gallery. And he made for us an NFT that, yeah, here you cannot see, but it's actually like dynamic. It's like an MP4 file that yeah, is the digital representation of the artwork. The real artwork is up for sale. The digital one is for free. So yeah, you can try it, and yeah, maybe in the future people will care about it. Like about all this like NFT stuff. Like yeah, personally, I don't know if like it will be something that will be like it's a trend that will keep being popular in the future, or maybe it's just a trend that will pass away in a few years. But it's a very good first use case to experiment with a new technology, because it's something that usually is not very high value, and it's low velocity, so it's less complexity involved in the operations. So it's a good first use case to experiment with a new technology. But yeah, of course, then the plan is try to build more interesting stuff on top of RGB, like higher value assets or like stablecoin or whatever. There is a question, yeah? You can wait for the mic so everybody.
Can I access my bitcoins from multiple devices?
You can. You mean your Bitcoin or your assets?
My assets, whatever.
It's very dangerous to do so, because the device needs to be perfectly synchronized between each other. So yeah, technically you could, but if the device they're not synchronized between each other, maybe they have a slightly different view on your balances.
Exactly, because I could access from two laptops. And then how do you resolve the double spending? Like I'm sending.
No, well, like there is no risk of double spending, but maybe you may see a balance that then you are not able to spend because the UTXO has been already used by the other device.
Like Lightning, like Lightning.
Yeah, it's less dangerous, because with Lightning, like you can actually, if you believe you are in an old state of the channel, you could do something that then you get the penalty transaction and you lose everything. With RGB, it just will be like transfer failed, and maybe you will not understand exactly why it failed, but it's not like you will lose anything. But still, I mean, it's not recommended to do so. I mean, maybe in the future we can try to work on some very advanced product that synchronize very well multiple wallets. But yeah, like there is a bunch of complexity to be aware of.
Okay, I was figuring if you can elaborate on the double spending. So I'm accessing from A and from B.
Yeah.
And from there I'm sending to there, and from there.
Yeah. So what will happen? Like from device A, you spend your UTXO that has the asset, and you send to your counterparty. From device B, you try to do the same thing to pay someone else. But what will happen when you try to do it? The UTXO that was the owner of those assets, it's not on UTXO anymore because it has been spent on the blockchain. So you will not be able to produce a proof that you are the owner of those assets. So you will just fail to create the RGB transfer to share with your counterparty. So you will say, oh, but the wallet say I have tokens, why I cannot spend them? So that will be the only consequence. But it's not like you will be able to double spend or you will lose anything. It's just that the wallet will believe that it's able to move token until it tries to do it, and when it tries to do it, it will just fail. Okay, so like yeah, if you want to play with the wallet, there is it's only for Android now. So if you have iOS, I mean, sorry for you, like, but it's not there yet. If you want to build the iOS version, like we actually developed a library. This wallet uses a library. Yes, sorry, I will go back to the slide if you wanted to scan the QR code. But we developed to build all of this. We developed a library called RGB lib. It's a Rust library that basically extracts all the complexity of RGB, because RGB has been developed in a very modular way, which has a lot of advantages, but also brings a lot of complexity for wallet developers. So we developed this library that provides a simple API interface. So you don't need to understand too much how RGB works in the background to build an RGB application. This library is in Rust, but we also made the bindings in Kotlin, that is the one that we use for the Android app, in Swift, that you can use for an iOS application if you want to build it. So you can build an iOS application without having to deep dive too much into RGB. You just use the library, and it should be like it should be at the end mostly like a front-end job. And we also have like bindings in Python. Yeah, we were looking to add more of them in the future. The library uses BDK in the background for all the Bitcoin functionality. So yeah, thanks to the BDK team for the amazing job on that side. And yeah, it's the one used in Iris Wallet. So yeah, here you have the QR code if you want to download the app, or you can just look for Iris Wallet in the store. I suggest to first download the testnet version, play with it a little bit, and then if you really want the mainnet collectible tokens, also download the mainnet one, but only if you really want to, and be aware of all the risk linked to it. If you have like feedback, support request, need for app, there is a Telegram group where you can send, or you can share like your UTXO where people can send you some test token. And yeah, so yeah, that's pretty much it for my presentation. And yeah, thank you so much. Okay, I see there is a question here. I don't know if, yeah, I guess a mic is coming. So.
Hello. One question. Why RGB and not Taro? You can make a comparison.
Oh yeah, sure. So well, basically RGB is an older project. Actually, it's been a project that it's been around. It's been work in progress for a few years, and Taro came out only later on this year. From what I can see, like Taro basically use pretty much the same specification of RGB, which is a good validation that RGB is a good model. So like yeah, like I'm happy other people are validating that RGB is a good model. The main difference is on the implementation side. I guess on Taro they prefer to build in Lightning Labs they prefer to build their own stuff. Maybe they prefer Go to Rust. I mean, whatever reason. But yeah, like from what I can see so far, the two protocols have pretty much the same trade-off. It's mostly the implementation that is different. And yeah, of course, like RGB right now is still experimental but working products. Why Taro is a bit behind on that side. But yeah, sorry, we were starting working on RGB before Taro was even announced. But yeah, they are quite similar. Also, like a difference that I see that is not technological, but Taro seems to me that is mostly like a Lightning Labs project that is developed for the Lightning Labs business goal, which is fine. While RGB is more like a community effort with multiple companies. Also, a lot of independent contributors. Like in the slide, I just put the logos of the company, but there are actually a bunch of independent contributors that are contributing to RGB. So like multiple people with multiple use cases in mind, they are contributing to RGB. So it's probably a much more flexible protocol for different use cases. While I suspect Taro will be something that is very well optimized for the business called Lightning Labs, and yeah, I mean, nothing wrong with that, but yeah, that may be a difference between the two protocols. Yeah.
How the routing, the validation routing algorithm works in technical wise?
Sorry?
The routing algorithm for the validation.
You mean on the for RGB transfer, or then for RGB on top of Lightning Network?
On top of the network.
On top of Lightning Network, yeah. Basically, you will have all the stuff that you have for normal like channel updates, and plus for every channel, for every time you do a Lightning payment, you will also have to share with your counterparty the proof of the new RGB transfer that is being committed to the Lightning commitment transaction, but will not be settled in the blockchain immediately. So yeah, basically you will have like a Lightning node doing every single Lightning node already does, plus what you need to do with RGB, so sharing all this RGB proof that prove that the asset is actually being transferred.
And on the other side, so the
receiver
blockchain
side, you mean?
yeah.
Yeah, the receiver side, we will just like need to receive them. So maybe you're also asking like how these proofs are shared technically. Okay, so right now in the Iris wallet, we just set up a proxy server, which is used to coordinate different wallets, which is also convenient if one of the two is offline. It's not the best solution because it's a bit centralized, even if you can like set up your own proxy server, but still, I mean, privacy-wise, it's not ideal. So we're also working on direct peer-to-peer communication between the nodes, which is much better privacy-wise. And yeah, so then people will be able to choose whether to have peer-to-peer communication with the counterparty, but they both need to be online, or to use a proxy server of either one of the two party or a third party service provider, so they can still do the transaction if they are not online at the same time.
Thank you.
Okay. There, I see a question.
Hi, from your speech, I also understand that you would like to implement like a wrapped Bitcoin inside RGB. So because you said you can send Bitcoin client-side validation and with more privacy, but how can you peg the Bitcoin in the Bitcoin network and Bitcoin, like a wrapped Bitcoin, I don't know.
No, well, I didn't say that you necessarily need to. I mean, it's something that you could do. I'm not sure, maybe it's like a use case that people are truly interested in. But yeah, you potentially could do. You could create a token that is a representation of real Bitcoin, but will be, I don't know, maybe there are other ways that I don't know about, but probably it will have to be somewhat centralized with probably maybe a federation that manage like the bridge between normal Bitcoin and RGB Bitcoin. Why this? Because yeah, we could do like an RGB Bitcoin that means new rat Bitcoin when you maybe like move real Bitcoin to a certain address or whatever. But then the other way around, it's not possible because the Bitcoin blockchain doesn't care about RGB. So it's like the same problem you have with sidechains actually. So yeah, probably you will need a semi-centralized bridge, which has its own drawbacks. But still, yeah, like probably there could be a use. I mean, people use like Bitcoins on Liquid, which is the exact same trade-off. So yeah, I'm expecting people to also create the rat Bitcoin on top of RGB to have some to leverage the features of RGB with a Bitcoin denominated asset.
Or maybe a one-way space chain like proof of work.
Yeah, I mean.
Everybody likes RGB more. Bitcoin will just move there.
Yeah, could happen. I mean, I don't know how many people will actually burn their Bitcoin, but yeah, I mean, it's a possibility. Yeah, I don't know who wants to go first, but okay. Oh, there.
Hello. I have a question regarding the Lightning Network. Do I understand correctly that I cannot route a RGB payment over a node which is not aware about RGB?
Yeah, basically the node needs to be aware of RGB, and yeah, so basically will be like a separate Lightning Network.
How would it change the Gossip protocol? How would I can inform announce my RGB channels to other nodes? Would non-RGB nodes would propagate this information to other nodes?
That actually you can do it, because in the Gossip protocol you can add some like extra metadata that not everyone needs to necessarily understand. So it could be something that only RGB aware node understand, but the others, they are fine with it, they will propagate it. So yeah, you can leverage the existing Lightning Network for the Gossip protocol. It's something that you can do.
Cool, thanks. And another question. Do RGB, again regarding the Lightning Network, add some other requirements on the node I run, apart from the requirements of the Lightning Network itself?
Oh, yeah.
Like liveness, backups, or anything else?
No, because like the requirement that you have for RGB, they're basically a subset of the requirements you have for lighting. Because with lighting, you need to be online all the time. With RGB, there is no security concern if you're not. With lightness, you need to do backups every channel update. In RGB, you also need to do them, but it's not toxic backup. It's not that if somebody finds your backup, they can broadcast an old state of the channel and you lose everything with a penalty transaction. It's just that it's just a privacy problem. So all the requirements for RGB are a subset of those for lighting. So yeah, no extra problem when you have RGB on lighting.
Cool. And when we have static backups for channels, can we implement the same for RGB?
Yeah, like I didn't look too much into it, but yeah, I don't see why it shouldn't be possible.
Cool, thank you very much.
Hi. Will the royalties business model that we commonly see on NFT project on other blockchain possible on RGB consider the privacy feature that you mentioned?
Yeah, it will be possible. I mean, it's not currently implemented in any of the schemas that are already there, but you could create a schema that defines that for a RGB transfer to be valid, you need to send some satoshis to the address of the royalty owners or whatever. So if nothing is be sent to this address, then the RGB transfer is invalid. So yeah, you could create a royalty model with RGB. It's not implemented yet, but yeah, there is no theoretical limitations on that.
Hi. What kind of use cases do you envision for RGB? In other words, are there like concrete examples of assets that you would like to see on RGB?
Well, for sure, I see right now the most popular kind of tokens in general in the whole crypto ecosystem are stablecoins. So I think, yeah, I think it's something that right now is very useful. I mean, in general, as long as the government doesn't censor them, stablecoin actually have a lot of utility for a lot of people. So that is something that like I would like to see in RGB, and that it can also be like not only for people that wants to do private payments, but also to have decentralized exchanges between like a stablecoin and the Bitcoin. People could do trading with atomic swaps on the same chain, so you don't even need like hash locks. There will be much more efficient and better atomic swap between Bitcoin and RGB assets. So yeah, it could be something that it could enable truly decentralized exchanges or decentralized trading in general in a sensible way. Then other than stable coins, well, I mean, I see like this art collectible are, I don't expect them to have like a massive value, but they are like a cute use case. And then maybe for gaming, I mean, I see a lot of interest about token. I'm not an expert about gaming, but I see people involved in gaming interested in this kind of stuff, so it could be like a valid use case. Then you have also the security tokens, but there you have a lot of bureaucracy behind it, like the real challenge there is not the technology but the legal aspect. So yeah, I really don't know how that part will evolve. Yeah, that is like a question that I get often. Okay, what is the acronym of RGB? It's like only a reference to the color coin, which was the first protocol for like to try to make tokens on top of Bitcoin. A lot of people forgot about them, so they don't get it anymore. But yeah, it's just a reference to the color spectrum. It's not like an acronym. I don't know. Maybe Giacomo had some suggestion for.
Hello. Is there some ability for decentralized exchange within the RGB protocol?
Yeah, I mean, it's nothing that is implemented yet, but yeah, it's actually, as I was saying, it's possible to do it, and also like with benefits compared to alternatives, because you could have like atomic swap between either RGB asset or RGB asset and Bitcoin, where the atomicity is provided by the fact that the two assets are exchanged in the same transaction. So you don't need like hash locks to coordinate two different transactions. The atomicity is given by the fact that the two assets are in the same transaction, and then so like I mean, I didn't put too much thought into it yet, but I expect that we could have a system where market maker propose a rate to exchange two assets. They prepare the partially signed transaction. They put it out there, like in our, like they can put it on a website or on a Telegram group, like wherever they prefer, and then a taker eventually will come, take the transaction, add this part of the transaction, sign it, and broadcast it, and yeah, you could have a truly decentralized exchange that is truly scalable. Yes, yeah, you have multiple, like how it happens in normal exchange actually. You have people that put quotes in the order books. You like it, you take them, nobody likes them, they just go like in the deeper part of the order book where nobody will never take it. And yeah, like I think that's like the only sensible way to actually have a decentralized exchange, because the Ethereum model is very convenient. But yeah, then it's not scalable because everybody needs to validate everything. While with RGB you could have like just people putting out in the wild this proposal for exchange, and yeah, and then it could be whatever communication channel to do discoveries of the proposal, and then you just take them, you put it in your wallet, hopefully with a good automation. And then you just broadcast the transaction and the exchange happen. Then maybe some it could happen that you try while you're doing you are taking an offer, somebody else does it faster than you. But it's the same thing with happen with centralized exchange. I try to fill an order and somebody, an high frequency trader is faster than me. So it's nothing new.
I'm not a tech guy, so I cannot evaluate if this is the case.
Okay.
But I have an acronym for RGB. Really groundbreaking.
Nice, good one.